Ho-da-ho! Welcome back. Today we're going to be talking about a new concept called elasticity. It's a concept that's going to come up over and over again for the rest of the year. So it's good that we get introduced to it. Okay, so elasticity is an economic statistic that measures responsiveness. We're going to talk about a lot of different types of elasticity this year. But just so you get some examples of how we talk about it, here are some examples. So the price elasticity of demand measures how responsive demand is for a good when its price changes. The income elasticity of demand measures how responsive demand for a good is when your income changes. The cross-price elasticity of demand measures how responsive demand for a good is when the price of another good changes. And the price elasticity of supply, which we'll get to later on, measures how responsive the quantity supplied by a firm is when the price of the good changes. So let's look at some graphs first before we get to some equations. Okay, so in this graph we have two different individuals' demand curves. So we've got Mr. Blue and Ms. Red. Initially, everybody starts off at point A, where the price is $3, and both Mr. Blue and Ms. Red consume 15 pints of ice cream. So this is the demand for ice cream. So then what happens is the price goes from $3 to $15. I don't know, maybe there's like a milk shortage or something. Mr. Blue slides along his demand curve to point C, and Ms. Red slides along her demand curve to point B. So Mr. Blue is now consuming 9 pints, and Ms. Red is now consuming 3 pints. So we would say that, so when you look at this, Ms. Red's demand changed by more. She went from 15 pints to 3 pints. So that's a change of 12 pints. Mr. Blue only went down by 6 pints. So because Ms. Red's demand changed more, even though she experienced the same increase in price, she responded more strongly to the same change in price. So we would say that Ms. Red's demand is more elastic than Mr. Blue's. Another way to say the same thing is that Mr. Blue's demand is more inelastic than Ms. Red's. So when you're looking at two different people's linear demand curves, in general, the more horizontal one of them looks, the more elastic it is. We need to be careful about that because the slope of a linear demand curve is not the same thing as elasticity. We're going to look at how to calculate it later. But in general, the flatter a demand curve is, the more responsive it's going to be to changes in price. Okay, so let's look at some extreme examples of like really elastic demand and then really inelastic demand. Okay, so this is a very elastic demand curve. The price starts at $7. Yeah. At $7, this person demands 0. It's too expensive. They're like, nope, not interested. When the price drops by only $1 to $6, all of a sudden they demand 20 units. So that's pretty responsive. So this would be a very elastic demand curve. Okay, so let's look at an example of actually perfectly inelastic demand. So in perfectly inelastic demand, you demand the same quantity no matter what the price is. So here, the demand curve is vertical. You are going to consume 9 units no matter what the price is. So whether the price is $2 or $7, you are going to consume the same amount. I'm not sure if there are any examples of perfectly inelastic demand in the world, but there are goods that are considered to be very inelastic in general, not perfectly so, but So gasoline is an example. If the price of gas goes up, a lot of times people will still need to buy the same amount of gas. They might try to reduce their gas consumption a little bit, but a lot of times there's not a whole lot people can do about that. And there are other examples along the same lines. Okay. Okay, so we are going to actually do some math to find a number that expresses elasticity. So there are a couple approaches to do this. The one that's used in the textbook and a lot of intro econ courses is you do the percentage change in quantity divided by the percentage change in price. So intuitively, that makes sense. So oh, I don't want a highlighter. All right, so if the price only changes by a little bit, but the quantity changes by a lot, a large percentage, that gives you a big number, and that's elastic demand. So intuitively, it makes sense. When you get down into the details about how to calculate it, you run into some problems. Notably, like if the price changes from $5 to $10, you get one number for elasticity, and you get a different number if the price goes from $10 to $5. Ideally, you'd like to get the same number because the price is changing by $5, and you're changing from the same price, $5 to $10 or back again. But using this approach, you get different numbers, and it's kind of lame. The real way to do it is to use the power rule. And so here's the definition for how we are going to compute elasticity using power rule. So this just means apply a power rule to the demand function. And this just means literally you put the variable p and then you divide it by whatever the given demand function was. And we're going to look at an example. Okay, this is actually pretty straightforward, so hang on. No, I don't want to close out. I want to do that. Okay, good. Okay. So let's actually look at an example. Okay, so here we are given a demand function Q equals 200 minus 4p, and we want to find the price elasticity of demand when the price is $10. So this is going to be important. You can only calculate elasticity at a specific price point. Okay, so first we're going to apply the power rule to the demand function. dq dp, well, the power rule when you apply it to the 200 is just 0 because the derivative of a constant is 0. And then the derivative of negative 4p is just negative 4. So dq dp is just negative 4. I'm going to write the elasticity equation up here. Okay, so we figured out the first part. And as I said on the previous slide, the second term here is just price over whatever the demand function given was. So this is P over the demand function. The demand function was 200 minus 4P. So now we just plug in the price that was given in the problem, which was $10. So we just plug that in for P. We get negative 4 times 10 over 200 minus 40, and we get negative 0.25. So the elasticity, the price elasticity of demand for this function at $10 is negative 0.25. Okay, so just some reminders here. Slope and elasticity are not the same thing. So this is what I mentioned a couple slides ago. So it's tempting to equate the slope of a linear demand curve with elasticity because of the link between steepness and elasticity. But we just saw in the example we did that the equation, that the demand curve was linear. So that means its slope is constant everywhere. But when we were doing the example, we got to this step, so that said that the elasticity is equal to negative 4 times P over 200 minus 4P. This elasticity clearly depends on the price. So along the demand curve, the price is changing. That's what the vertical axis is. So, the price changes along the linear demand curve, which means that the elasticity will also change along a linear demand curve. So the slope of a linear demand curve is constant, but the elasticity along a linear demand curve is not constant. Okay, and then there's just some vocabulary guidelines down here. If elasticity is less than negative 1, we say that demand is elastic at that price. If elasticity is in between 0 and negative 1, so that would be the case of the example that we just did, we got negative 0.25, I would say the demand is inelastic at that price. And if the elasticity of demand is exactly equal to negative 1, we say that demand is unit elastic. It's neither elastic nor inelastic. So negative 1 is like the cutoff point. If you get an elasticity that's less than negative 1 over here, that's elastic. If it's in between 0 and negative 1, that's inelastic. Oh, I skipped a question. I'm going to go back. Oh, don't have to. Okay, so the question down here at the bottom says, will the price elasticity of demand always be negative? Why or why not? So I'll give you a second. Think about that. Put your answer in play pause it, and then I will answer it. Okay. The answer is yes. So if we think about the equation... So let's think about the sign of all these things. Okay, so the sign of P here, that's going to be positive. Prices can only be positive. The quantity demanded at any given price also has to be positive. We're not looking at negative demand in this course. So that means that the sign of elasticity, the price elasticity of demand, is going to be controlled by this. What happens to the quantity demanded when the price goes up. So we know this term has to be negative. The law of demand says that price and quantity demanded always move in opposite directions. So when price goes up, you're going to consume less. When price goes down, you're going to consume more. So since price and quantity always move in opposite directions, that means that dq dp is going to be negative. So the price elasticity of demand is always negative because of the law of demand. Okay, here's an example problem for you to do. Go ahead and try to work this out. Put your answer in for part A, and I'll put the solution up in a second. Okay, here's the solution to part A. I've just got the formula for elasticity right there. When I apply the power rule to this demand function, you bring down the negative 1. Then you reduce the exponent on P by 1, which gives you negative 2. And then P over 20P to the negative 1. This is just the demand function that was given. I just did some simplification. I popped the P to the negative 2 to the denominator to make the exponent positive. Did the same thing here. I moved this P to the negative 1 up to the numerator. That's where this P squared came from. And then everything cancels and you get negative 1. So the price elasticity of demand for this function is negative 1 everywhere. So that brings us to the answer to part B. Is the price elasticity of demand constant along this demand curve, and how do you know? Go ahead and put your answer in play pause it. The answer to part B is yes, it is constant. So since we just got a number for elasticity, we just got -1, there's no P involved. That means it's going to be constant no matter what P is. And we are out of time.